Okay, so this is a limiting reactant problem. The first thing is that you're given this word equation. Aluminum reacts with chlorine to produce aluminum chloride. So aluminum is Al, chlorine is a diatomic, so it's Cl2. And so we've got Al and Cl2 as our reactants, and then it says produce, so we know that that means it's our yield sign, and it says aluminum chloride. Aluminum is in group 13, so that means that it is Al3 plus, and chlorine is in group 17, which means it's 1 negative. So when we cross these, we get AlCl3. Okay, so that's where that comes from. And then you're supposed to balance this equation. And you have to do all of this before you actually do your conversions for limiting reactants. So we have aluminum and we have chlorine. We don't bring the subscript down for the chlorine, we just do the elements that we have. So we have 1 aluminum on the reactant side and 1 aluminum on the product side. We have 2 chlorines on the reactant side and 3 chlorines on the product side. So our chlorines aren't balanced. We have less chlorines on our reactant side, so if we multiply this by 3, we get 6 chlorines, and we have to put that 3 in front of the chlorine so that we have a coefficient. And now our chlorines on the product side are not balanced either. We multiply that by 2 to get to 6, which means we need a coefficient of 2 in front of our aluminum chloride compound. But that means we also have to multiply our product aluminum by 2 because it's part of that compound. So everything in that compound is multiplied by 2. Once we do that, our aluminums aren't balanced anymore, and we need to multiply our reactant side aluminum by 2 as well. So the balanced equation is 2 aluminums, which are elementals, so they're solid, plus 3 chlorine, yield or produce or make 2 aluminum chlorides. We're going to use this balanced equation in the next step when we actually go to determine what our limiting reactant is. So we have to have this to be able to do the next step. So now that we actually have our balanced equation, we can start this problem. It says if you begin with 3.2 grams of aluminum and 5.4 grams of chlorine, which is the limiting reagent? Well, you have to know your reactants are aluminum and chlorine, and this is our first reactant, reactant A, and chlorine is our second reactant, reactant B. So steps for finding limiting reactants, you need to convert the mass that you're given for your reactant A into how much you would have for the reactant B. So that means that this is a conversion problem. It's a full stoichiometry problem. And we know that we have 3.2 grams of aluminum. And we know that we're trying to get to how many grams of chlorine gas it would take to react with that 3.2 grams of aluminum. And then what we're going to do is we're going to compare this mass that we find, which is going to be our needed mass, to this mass that we're given in the problem to see which of these two substances, the aluminum or the chlorine, is our limiting reactant. So we need to set up our equivalent statements. In order to get from grams of aluminum to grams of chlorine, we have to go grams to moles of substance B to grams of substance B. And to get there, we have to do 3 conversion statements, because if you look, we have 3 arrows here. So the first conversion statement is to get from grams of our substance A, aluminum, into moles of that. So that's just molar mass. 1 mole of aluminum is equal to blank grams of aluminum. And we just read that straight off of the periodic table. And on the periodic table, aluminum has a mass of 26.982 grams. And now at this point, we have gotten out of the grams and into the moles using this conversion statement, so we're actually looking at it backwards. And now we need to go from moles of aluminum, our substance A, into moles of chlorine, our substance B. To do that, we have to use those balanced coefficients from our equation. And if you remember our coefficients from our equation, we had 2 aluminums for 3 chlorine gases, giving the aluminum chloride, 2 moles of the aluminum chloride. So that means from our coefficients that we have 2 moles of aluminum, and that's equal to our blank moles of chlorine gas. And remember, these are just the coefficients in front from the balanced equation. So 2 moles of aluminum for 3 moles of chlorine. And then the last one is right here, where we go from our moles of our substance B, which is chlorine, because now we're in moles of chlorine, into grams of chlorine, the mass of chlorine, and we need to use the molar mass of chlorine to be able to do that. Chlorine is a diatomic in its elemental state, so we actually have to calculate the molar mass for this. We can't look at just straight up on the periodic table. So we have 2 chlorines, so that's 2 times 35.453, and that equals 70.906. So every mole of chlorine has a mass of 70.906 grams. At this point, we can actually plug into our equation and get all of our units set up the way we need to. We are beginning, remember our mole map, with grams of substance A, which is aluminum, and going into moles of aluminum, and then going into moles of chlorine, and then going into grams of chlorine. So we're starting with grams of aluminum, and we're going into moles of aluminum, and then moles of chlorine, and finally grams of chlorine. All right, in order for us to actually get to that, we have to use these equivalent statements. So if we're trying to get from grams into moles, we have to use this first equivalent statement to go from grams into moles of aluminum, which means that we have to cancel out our grams of aluminum. So all we've done is taken this equivalent statement right here, and we're going to put it in fraction form. So since moles of aluminum is on top, we need grams of aluminum to be on bottom. The other way to think about this is this way. If we're given grams of aluminum, we need to cancel that unit to be able to get into the unit we want. And we're just going to continue to do that. So if we want moles of aluminum, that means we need to cancel it out and have moles of aluminum on bottom. If we are trying to get out of moles of chlorine, we need it to be on bottom. So that's what we've got on here. So moles of aluminum, moles of chlorine gas. And again, these are just coming straight from these equivalent statements. So moles of aluminum, grams of aluminum. That's this first equivalent statement. Moles of aluminum, grams of aluminum. Second equivalent statement, moles of aluminum, moles of chlorine, or moles of aluminum on bottom, chlorine on top. And then the last one, moles of chlorine to grams of chlorine. Moles of chlorine on bottom, grams of chlorine on top. And then if we look at this, if you set this up correctly, your units cancel. So our grams of aluminum cancel out, our moles of aluminum cancel out, our moles of chlorine cancel out, and we are left with our grams of chlorine gas, which is what we want. So at this point, we can substitute in our numbers and solve this. So substituting in our given, we were given 3.2 grams of aluminum in the problem. Molar mass, we get from this first equivalent statement, 1 mole is equal to 26.982 grams of aluminum. So we just stick those numbers in where they go. 1 mole of aluminum is 26.982 grams of aluminum. And we do the same thing for the next one. 2 moles of aluminum, 3 moles of chlorine. So our 3 moles of chlorine is going to go on top, and our 2 moles of aluminum is going to go on bottom. 3 moles of chlorine, 2 moles of aluminum. And now we're on to our last conversion statement or equivalent statement. Moles of chlorine to grams of chlorine. Grams of chlorine is on top, so we're going to put the 70.906 on top. and 1 mole on bottom. All right, so then it's just a matter of doing the math. There's two different ways you can do this. You can either multiply straight across the top and get a number and then divide that by what you multiply straight across the bottom, or you can do what I like to do, because then it's just a one step where you understand that everything on bottom means divide and everything on top means multiply. So you can go straight through this problem. 3.2 divided by 26.982 multiplied by 3 divided by 2 multiplied by 70.906. It's doing the same thing, but you can do whatever works for you. So if we do that, oops, I apologize. Let me fix that. Okay, so 3.2 grams. .2 grams divided by 26.982 times 3 divided by 2 times 70.906. So when you do this on the calculator, you get 12.6139. Okay, and then if we go and we look at our significant digits, we have 2, this is 5, this is exact, and this is 5. So we need to take our answer to 2, which means that this rounds to 13 grams of chlorine gas. And then if we look back up at our problem, we were given 5.4 grams of chlorine. So if we compare our 13 grams, what we needed, to what we were given, 5.4, our needed is bigger than our given of 5.4 grams, which means that our chlorine gas is the limiting reactant, since needed is bigger than given. Alright, so now that we know what our limiting reactant is, we know that it's the chlorine, we can actually figure out how much product we're going to make. That's the next step. So we know that we were given 5.4 grams of chlorine in this problem, and we are trying to figure out how much aluminum chloride we can make. All right, so if we look at this, we are doing mass to mole to moles to mass, and this is going to be the aluminum chloride, and this over here is going to be the chlorine gas. So we're trying to get out of the mass of chlorine gas into moles of chlorine gas and then into moles of aluminum chloride so that we can get to the mass of the actual product that is made. So we need to do our equivalent statements, and the first one is to get out of the mass of chlorine, so we use molar mass for that. So 1 mole of chlorine gas is equal to blank grams of chlorine. We actually already calculated this. You did this just previously to do the limiting reactant. 2 times 35.453, which is 70.906 grams. And then we have to use our coefficients to go from moles of chlorine into moles of aluminum chloride. Okay, and remember that's the coefficients from the balanced equation. So back to the beginning, it was 2 moles of aluminum with 3 moles of chlorine gas reacting to form 2 moles of aluminum chloride. So we have 3 moles of chlorine for every 2 moles of aluminum chloride. And then the last conversion we need to make is to go from moles to mass on aluminum chloride. So that's another molar mass. So we have 1 mole of aluminum chloride equals blank grams of aluminum chloride. And you have to calculate this. You have 1 aluminum, and aluminum has a mass of 26.982. And we have 3 chlorines. So 3 times 35. Sorry, I'm in trouble with my stylus. 3 times 35.453. All right, so we multiply through 1 times 26.982 is just 26.982, and then 3 times 35.453 is 106.359. So once we add those up, we get 133.341 grams, and that goes into our equivalent statement. And then we're ready to do our equation, where we put all of our units in. So we're given grams of chlorine. Now remember, on our mole map, we can go straight across here. Grams of chlorine mass to moles of chlorine to moles of aluminum chloride to mass of aluminum chloride, and that goes straight across the top. Grams of chlorine to moles of chlorine to moles of aluminum chloride to grams of aluminum chloride. And then you just have to cancel those units out. So we start here with the grams of aluminum chloride. We need grams of aluminum, or sorry, not grams of aluminum chloride, grams of chlorine gas, which means we need grams of chlorine gas down here. And we keep going. We've got moles of chlorine here, which means we need moles of chlorine underneath so that that unit cancels. And finally, we've got moles of aluminum chloride. We need moles of aluminum chloride on bottom so that they cancel. And then substituting in your numbers and solving this. We are given, up here in the problem, 5.4 grams of chlorine. And it's not written on this page, but it was written in your first part of the problem. So then we just start using our equivalent statements. 1 mole of chlorine to 70.906 grams. 1 mole of chlorine to 70.906 grams of chlorine. And then we're on to our second one, 3 moles of chlorine to 2 moles of aluminum chloride. So that means the 2 moles of aluminum chloride has to be on top. And our 3 moles of chlorine gas on bottom. And then we're to our last one. Our last one, grams and moles. So 1 mole of aluminum chloride is equal to 133.34 grams of aluminum chloride. Grams is on top, so we got 133.341 grams of aluminum chloride. And that's all over 1 mole of aluminum chloride. So what are we doing math-wise? We are dividing 5.4 by 70.906, multiplying by 2, dividing by 3, and then multiplying by 133.341. If you're not comfortable doing this, again, like I said, multiply straight across the top, get yourself a number here, multiply straight across the bottom, get yourself a number, and then divide the 2. So when we do the math on this, we get 6.7699. And then the last step is to do our significant digits. So we have 2 in our given. We have 5. These are exact, remember, they're moles to mole ratios. And then we have 6 in this other mass. So our answer needs to go with our given, which is 2. The 6 rounds the 7 up, and this becomes 6.8 grams of aluminum chloride can be made. And that is how you do a limiting reactant problem. So remember, for limiting reactant problems, you have to first make sure your equation is written correctly and balanced. Then you go from the mass of your first reactant into the mass of your second reactant to figure out which one is limiting. You compare the mass that you find, that's your needed mass, to the given in the problem. If that number is more than what is given to you, then that means that's the limiting reactant. If the number is less than what is given to you in the problem, then that means it is the excess reactant. And then you take whatever your limiting reactant's mass is that you're given in the problem, and you can figure out how much mass of product you're made by doing stoichiometry, and that's what we just did on this last segment.